Thank you, Brian. Appreciate it very much. Great to see everybody here today. Our panel's on the impact of data-driven learning and large language models. That's a lot of fun. I always try to relate before I get these guys. And so I think it's important that we talk about what data is and why data is important. It reminded me of a story that just happened last night. We were out to dinner, very nice place called the Cathedral, big, super cool new place, really lush. We're sitting at a table having a very nice dinner, and my good friend Jeff Law drops his spoon on the floor. Within seconds, like 2 seconds, waiter comes over, pulls the spoon out of his pocket and puts it in front of Jeff. And I'm like, that's amazing. How do you know that? And he goes, we did a survey. We used all of this data, and we found that 72% of the time a utensil hits the floor, it's a spoon. Anybody else knew that? I didn't know it. I worked in restaurants for a long time. I didn't know spoon was it. So I was kind of blown away. But as the guy was saying this, and bear with me a little, he had a string coming out of his fly. So that was weird. And so I asked the question, I go, what's the deal with the string? And he said, we found after COVID, it was far more efficient when we go to the bathroom is to use the string to help us out and be able to not have to dirty our hands and all that. And I said, this is absolute garbage. I said, I don't believe you at all. And he goes, no, really? And I said, well, how do you put it back? And he goes, the spoon. Oh, I'm sorry. Data's important. Jeff didn't want to use the spoon after that because that's data. So I think what's really important as we start today, we really have an understanding why data is so critical to our success and what we can do with it. Since I've been in this industry, as Brian pointed out, for a long time, we did actions. We did stuff based on actions, hoping things worked out. In the last 5 years, we've focused on understanding what those actions were and how we can use the data associated with those actions to make better decisions. And we have one of the most qualified panels I've ever seen on paper here to discuss this with us. So I'm really excited about this. We are going to ask a few questions at the end. I'm going to ask you to hold off until the mic gets in front of you because I want to record these as well. That's the other thing I do. So let's make sure when we do questions at the end, we're using the mic. Okay? All righty. So the first question, and I'm going to start with Kyle.
Oh, God.
All right. So Kyle, the first question is, what trends have you seen in the widespread adoption of data-driven approaches over the last several years, and what has been the most impactful?
There's when it comes to, you mentioned large language model, there's a lot of hype right now around generative AI, particularly large language models, ChatGPT. I think everyone's heard that. Really a lot of attention's been on that this year. And that's one of it deserves the hype. There's a lot of really amazing things that you can do with it. And our industry is no exception to that, right? Especially when it comes to things like natural language processing, or NLP as we call it. It really puts these complex outcomes and insights into plain English, right? Or in layman terms, really. And you can just do so much with it. There's a lot. We can get into. I think one of the things that's driving such adoption and expansion in AI is the ability, the ease of access to it, right? And so Justin and I were just talking a little bit at lunch about this, and there's just so many tools that are available. There's a lot of open source libraries, open source data sets. You have, the largest programming language in AI is Python, and that's a very easy language to learn. You also get into these offerings which are allow you to prototype and do proof of concepts with AI very easily, and quickly with low effort. So a lot of that comes in the form of low code or no code type of things. So you don't have to know how to code to do these prototypes, and you can see what ideas you have that hold water, right? That are worth exploring further and worth the investment, to take it to the next step and take it to the next level, right? And The other thing is, you know, you're getting into these tools that allow you to just do it a lot more quickly, a lot more easily, even AI for AI, right? A lot of the work involved with machine learning is scrubbing data and making it structured and relating data to other data. And now you have tools that can really automate that or make it very low effort compared to what it used to be. That's some of the things that I think are most impactful.
Yeah, two sort of themes that I think stick out to me. The first is de-siloing data sources. So all these models, regardless of what they are, they all require an enormous amount of data to train on and develop, test, and, self-improve. So to do that, you need access to the data, right? So we were talking at lunch about how, the same conversation everyone's having today about generative AI, we were having, about machine learning in general 3 or 4 years ago, and then 3 or 4 years before that, it was IoT. And all of these themes keep coming back to having a similar set of challenges. And I think one of the key ones is de-siloing the data. So the two big trends I see is people that are successfully using these new technologies, whether it's generative AI, whatever it is, made investments early on and continue to double down on their investments to de-silo all their data sources and try to normalize it as much as they can. And the ones that aren't successful at doing that are struggling a lot with, well, I can't deploy the models, I can't develop, refine this capability because I don't have the data and the infrastructure in place yet. And a big root cause of that is the data is not normalized. It's all siloed. It sits in a different place in the organization. It's in a different system, things like that. That's definitely a big one. I think the other key piece of it, and this is the role we're playing as partners with Earth, is most of our role in this kind of big data and AI ML journey is us bringing different types and new types of data to that model development, right? So you have big data. We were talking at lunch. What are other externalities, or what are other sources that could cause issues at dig sites, right? And so we were talking, and Kyle kind of very politely was like, in a way, asked like, well, what would things like geohazards or landslide or anything to do with terrain have anything to do with, locating, right? And I gave an example, which is you can have a toe of a slope that hasn't critically failed yet, but is shifting the ground at the toe feet per year. So the ground you think you located 3 or 4 years ago, where you think the line might be shifted 3 or 4 feet underneath the ground because that toe is moving. So those are like things that we can help with. We can detect those things. We can measure those things with satellite radar. We can do things with LiDAR data, and we can help feed those data sets into those models and help improve the predictive power of them. So that's I think the trend I've seen in general is going outside of the traditional realm of the data that you're using to train models, and bringing in newer, different types of data to really understand what are the factors that are really driving these events from happening. Is it purely operator? Is it purely the line locators or the excavators, or are there other things? Is it the climate related things? Are there there these geophysical related issues? Are there all these other things? So again, I think the people that are having more success with this are looking to newer, different, diverse sets of data to bring into those models to improve their efficacy. So.
All right, let me try to add to that. So I think this panel is going to be largely a technology panel. We're talking about data, we're talking about AI, or heard some technology terms already. But I think when we think about widespread adoption, we shouldn't keep in mind that doesn't have more about people who adopt. No? So just to emphasize this point, so when we say what trends have we seen in the last few years, one big trend is that people are willing and aware, is they're willing to use this and aware that there's benefit there. It's really important to point out, Like 6 years ago, if we would have sitting and said, oh yeah, let's solve these problems with AI, we would have laughed us out of the room, to some extent. And something rightfully so, And so what we see is like, on the one hand, people are aware that not every problem is to be solved by AI and data, but it is incredibly valuable. So people are building data stores, not siloed. people are then willing to build models on this, trust domain expert to do this, and actually use the models. This is a really big difference, no? And this doesn't just affect like sort of your community only. Let me give you one other example, which is more like a research example, but if you look into weather forecasts, okay, nothing to do with really what we're discussing today, you know. Meteorologists are really a community that's very much based on like physics and principles of simulation, no? And there's been a revolution in the meteorological community in the last like 6 months. They're starting to look at massive AI models to like actually make weather forecasts at scale, for example. No? So you see, communities are willing to adopt these things. That's the first thing. The second thing that happened, by the way, though, is that also maybe the AI people are more receptive towards domain knowledge in the communities. So in 2014 or 2015, you would have often seen a startup saying, "Oh, we solved this problem with AI," you know, claiming that, "Oh, AI can do everything," you know. And now there's maybe more awareness also that of what the limits there again are, even if they're shifting. You know, and I'll give you one example of this. You know, in the collaboration that we have with our partners at Earth, obviously, we said earlier we're looking into like detection of methane events using satellite images, no? And the algorithms we use are like a mixture of both, you know? There is signal processing and like an understanding of physics and an expert understanding that tells you why you might see methane in a satellite image. And there's an AI component that cleans this even up, okay? So let me just sort of say, what I'm trying to emphasize is adoption doesn't happen without people who are willing to adopt it. And I think now we've arrived at the mindset that we have these nice discussions this morning about, you know, data that Earth has, algorithms people have, and obviously you're the audience who say this is interesting to listen to. And I think this is really key.
Nice, nice. I think it's a really great explanation. I found interesting in that discussion is thinking how this is affecting our industry, right? And so the siloed data is a very interesting conversation because right now I've been approached by many people in the industry that are trying to recreate what a one call center does. They're trying to figure out what lines are in the ground by just using publicly available data. I think in the next few years, we're going to see a very big approach of using all the data that we spend so much time to protect is it's going to be a lot more open. So what happens when all that data becomes more open and what opportunities that engages us? And I think one of the things that everybody I think should feel very happy about is we used to never have any kind of experts from anywhere else in the industry sit in any of these things because no one cared. No one saw any value of participating or doing any of that. They just said, there's the guys that paint dirt, who cares? But the reality of it is the most valuable data at most companies exist in your hands, and being able to leverage that data and make better decisions is incredibly important. So now we have new people like IBM and Boston Geospatial coming in saying there's real value here. So I think it's interesting because not only are they saying there's real value, but they're looking at it from a very different perspective than we ever looked at it. We never talked about slope. We never talked about weather patterns, and that's what we're doing today. So I think the opportunity is great. Johannes, let's start with you on this one. What emerging trends and technologies do you anticipate will shape the future, and what challenges and barriers do you see?
So, I kind of touched on this already actually in the first answer to this first question, okay? So, he was talking about ChatGPT, okay? And let me put this into context a bit what happened there, okay? So, you're probably aware of the fact when we say ChatGPT, what we usually mean, that there's some sort of AI model out there for which you can communicate with text. You know, you can write, it's like, hey, write my admissions office for, write my application letter for university, and you get a nice college application letter, you know? Or you say, write my homework, and then the thing does the homework for you, you know? Maybe it's right, maybe it's not. So why did that get possible? Okay, let me sort of say some very simple terms. Sorry for the term simple, but let me try to explain what actually happened there. Research in language and AI has been going on for like, decades. But what happened in the last like 3 years is that people started making these models absolutely massive, okay? So to put them to some scale, the largest language models these days have like 180 billion internal parameters. You know, it used to be like a few years ago, suddenly all of millions, okay? So they made very, very large models. And the crazy thing that happened is when they made these models very large, suddenly they became much more powerful, much more than anticipated. There was sort of a jump in just how powerful these models are. Now, why did this matter to you, okay? And one thing is that, yeah, there might be very nice applications coming out of these ChatGPT type of things, okay? I think we might hear some things also from Matt or products there, but the idea is you can now do things with language. But what also is possible there is the following. These models become reusable, okay? So I'm actually probably explaining this badly. Let me try to start again. All right, I'm explaining this badly. The point is this, okay? Typically, when you train an AI model, you need a lot of data. Okay, that's what we said earlier. We said data is there and this is very valuable. But there are certain domains where you don't have a lot of data, okay, where observation is very limited. So what's now happening here with these very large models is that people train a large model in a domain-independent way, and then others can use the model with very little data in a specific domain. So, you know, in these language models, they get trained once on lots of web pages, you know, and then you can tune the model to your own application. And now people are doing similar things with satellite images, with weather, with time series, with sensor data, okay? So a very large model gets trained once on maybe all the satellite images in the world, on all the weather data in the world, on all the time series data in the world, and then it can be tuned to much more domain cases, okay? So the consequence in the next few years is going to be that you might start consuming these very large models as well, and that might unlock new use cases, okay? So I hope that makes some sense.
I think Kyle hit on I'll talk about the infrastructure really quickly. I think in the last couple years in particular, I think what's proliferated is both the models themselves, not just the models. There's sort of, I like to describe it as there's machine learning and AI as like a research field that will continue to innovate, and that'll continue, and people like him will be at the forefront of that, and his colleagues will be doing that. But there's another cohort who have figured out a way to make it very consumable for commercial use, for operational use. And that has exploded over the last, in particular, at least from my observation, the last 3 or 4 years. The amount of libraries and open source code and algorithms now that exist that you can very quickly go to set up, deploy, and develop models, test them, train them, iterate is massive. There's no need to go develop a lot of these new models from scratch. There's so much you can do kind of turnkey out of the box for the most part. That's huge. The other trend, and that will continue, that's these sort of upstream, these advancements at the state of the art move and the frontier moves forward. There'll be people that help synthesize and stratify it down for the technologists of the world like me to apply it to problems, right? The other is the infrastructure. Like cloud computing is so cheap. It's commoditized. So you can really inexpensively test and train these things really quickly. And so you can start out with experiments, really rapidly deploy them and test them and not cost a ton of money. And then you can afford to fail, right? So you can, for thousands of dollars, a couple $1,000s, go over a week, days, test these theories, iterate and improve. And you just couldn't do that, like maybe even as soon as like 5 years ago. At least at the economy of scale that you can today. So that's like on the infrastructure like side of things. The other trends that I think are really fascinating to me, as like, you know, from a research point of view, that I think is really interesting and could really drive things forward. I'll mention one of which ties into what you're just saying is synthetic data. So one of the biggest challenges with training these models is the data. And this is a problem for everything from stock predicting to looking at satellite imagery to trying to develop algorithms that make self-driving cars like safer, right? Data is very, very thin. It's not, and even if you like organize it, it's still just like a lack of data. So some really cool innovations that are happening is, well, why not like we create our own data sets, right? And this is actually happening a lot in remote sensing. We've seen this a lot in our kind of sector in the defense side, training algorithms for like target recognition, for example, right? There's not a huge data set out there that exists of what the radar cross-section looks like that you can go publicly look at for all the different tanks in the world that get manufactured, right? But if you have drawings or a rough idea what they look like, and we can simulate what a radar image might look like, then we can create a huge amount of input data to train models. So this is like a whole new area that's really exploded in the last few years. It's really fascinating. It's really exciting, is the ability to create synthetic data to train these models. In the last, I think, which is another really interesting technology like vector, is new approaches to how you think about building these models. So a lot of the classical sense is like, all right, I'm trying to develop a algorithm that better detects people walking out in front of a car, a self-driving car, or trying to predict when the guy next to me in the lane is going to cut me off and come into my lane, right? So, you know, one method is, let's just have a bunch of video streams and pictures to kind of relate the telemetry of the truck next to me and try to understand intent, like from like how the car is wobbling and moving in the lane. There are companies, for example, that are taking a different approach, and rather than trying to understand the kind of the kinematics of what's happening in the frame, is to try to go a level deeper and instead build models of the person driving the car. If I can build an accurate model that helps me understand the decision-making skills of the person driving the car, if I can relate that to what they're doing and I'm seeing in the video, I don't need to train the algorithms on massive amounts of pictures and images and what people have done in the past merging in lanes. If I can understand the nature of what are the leading causes of him leading up to like not looking in his left lane and merging over. If I can understand what are the determinants that create that and replicate that environment, then I might have better predictive power and ability to predict the intent of that driver doing that than by just looking at what's going on in the camera. So there's a lot of really interesting like new trends in areas where people are trying to improve the state of the art, but those are two really exciting ones, is sort of new approaches to building these models philosophically, and then the other is synthetic data is huge. And it's really trying to really solve a big problem, which is this data bottleneck issue. So,
in terms of new technologies that are emerging, I see there's been a focus on explainability. What that is you can think of a predictive model you could think of it as a black box, right? You don't get to see what's inside of it. You put something in, it spits something out, and you don't really know why. Lately, we've been focusing on explainability at Earth, but also as an industry in general. In fact, there are some industries where explainability is required for legal reasons. A good example is insurance, right? When they're quantifying risk or predicting risk, they need to know why it's risky legally, right? And a couple other ones. One is computing these predictions on the edge, right? So on your individual devices instead of in a cloud server, right? So it's almost like distributed computing, but distributed AI. And that comes with all the benefits of your typical, edge compute. It allows predictions to come much faster because you don't have to send the data up or send the data down. It's just all done on your local. And you see that in cars, right? I mean, the cars aren't sending data to a server and then getting it back. They're generating the predictions in the car. Finally, the last thing that we're seeing, especially with large language model or generative AI, is multimodal learning. It's not just text, right? We're also generating and using for training images, videos, all sorts of different types of data and multimedia. In terms of concerns, there's a few. I mean, there's hyperautomation, which is basically the idea that there's going to be a lot of job displacement, right? Or job displacement. Some of these jobs that are used today, may not be around very much longer. That's more of a societal, I think, challenge, right? Not something we're going to solve here in damage prevention. But another one is authenticity, right? We've all seen, there's a lot of deep fakes. You don't really know what to believe anymore, maybe you do, maybe you don't. But you see these things, you think they're real, and they're not, and that's a concern, right? And then you have, also data privacy, especially with these large language models. You saw when ChatGPT 3 came out, everybody was using it like crazy and figuring out all these cool things that you could do with it. They were also figuring out how to trick it into giving you information that you probably aren't allowed to have. And you actually saw, I think, OpenAI and the creators of these large language models kind of pull back a little bit to say, we need to rethink this, right? Because we're going to get in trouble, right? It's a liability for us if you discover something using our generative AI that you're not supposed to be able to learn because some data snuck in there during training that shouldn't have been.
Interesting. I think the scariest thing I heard is that they're going to have a predictive model of how people drive, and I live in Florida, and I can help you with the image of the person that has the turn signal that just goes on. There's a very particular audience that I'm very familiar with that does that. So anyways, you don't need any videos. I can point them out. I'm pretty good at that. Okay. So I think what's interesting is we kind of get in. This is, if you guys really want an exciting evening, you should sit at a table with these guys when they have a couple of drinks and start talking about all this. It's crazy. They get out of control. But what I found incredibly interesting, especially from our perspective as we're starting to leverage more data, it's like the human involvement. Like how does that, like how can we add the human element into this very complex process and gain value out of it, but also allow it to ensure, because a lot of stuff I hear is the models are predicting what our gut thinks, right? We go, oh, that makes sense. We're going to keep training this and that outcome is what I think. But that requires a human. So I'm curious of the human participation, how it's better and how we can leverage that in the future. So Justin, why don't we start with you? Oh, yeah.
Yeah, I'll start.
Perfect.
I'm a little bit more optimistic. I think and I think it's just going to get worse over the next couple of years. Like the pessimism around these technologies and like, oh, it's going to be so disruptive to like the economy in terms of like job, like the workforce and stuff. I'm a little bit more of like, let's look at the past. Like I think people thought the same thing when like the computer boom happened, right? Like and they said, and it didn't. And I mean, to a certain extent, it happened, but it didn't happen like overnight. Like if I hear another person on CNBC or something talk about how like in a year, like lawyers are going to be out of a job, which would be amazing for a certain extent. It's just driving me crazy. The computer revolution happened, and yeah, there were people that lost their job, but there was also a massive boom in like the productivity went through the roof. The economy, there were like a lot of good things that happened. I think that that's what's going to happen with this. Is it's going to make people's jobs easier so that they can do more value-added things and spend their time more productively. So like I'll give a really good example because this is like we're still really early in like GIS, for example, and using these natural language models and things like that. But a really cool example I saw the other day, because there's a lot of experimenting going on. How do you use like this stuff in like ArcGIS, in your GIS environments, right? So a really cool example the other day where they developed a simple workflow, which they're like, this person's used to like getting raw LiDAR point data in and like processing it, cleaning up, doing all the detection of like, okay, this is a tree, right? Then they have the LiDAR, then they have the processed LiDAR data, and then they're doing catchment analysis, right? So like, you can think of a catchment as like, if I had a cup of water and I threw it up in the air and all the water hit the ground, where's it going to drain to, right? So like the cool thing there was they prototyped a model that like should be like, here's my raw data. I want to process it and do this. I'd like to create a output TIFF of the terrain. I want a classified layer showing where all the trees are, and then I'd like to have a like catchment done, right? And that's it. And it like did it. I mean, it took a while to run, right? Because it was doing it like a computer. That's like that alone would have taken one analyst or like GIS expert, I don't know, maybe like a week to do, at least a week, depending on how big the scene was. And a lot of that's a lot of manual work and a lot of like quality checking. But I think that's going to be really where a lot of the benefit of these things are, is using human knowledge of like, what are the QA checks I do for these things? Like the things that are like huge value in the work stream, but are like laborious, right? Like you really want to be spending your time error checking things. Like it's important, so it has to be done. So I think that's going to be the role going forward. I think once we get to that, I think it's still early, is like, how do we take best practices and this like institutional knowledge around how to do specific activities, and like what are the processes we create institutionally to like map those into rules and things we can feed into these technologies that help us like be more productive, save time on repetitive, like just boring work that nobody really wants to do, that everybody's looking for a reason to like save money on, right? So I think that's like there's probably many facets where like human in the loop can use these technologies, but I think that's going to exist for a long time. Like these models are going to be super useful only if a human can train them to be like these are the steps, these are the things to do. Like there's some extent to like the learning can like in the models can like synaptically figure out. But like if you're like trying to do this, develop workflows and like institutionalize knowledge, like I was always fascinated at like NASA has this huge problem with like labor turnover, right? Like engineers come in, they turn over, they get promoted, they go to outside of industry, and even in like the non-technical parts of the agency, they have this problem with people that have like knowledge of like program cost estimating, right? And so what ends up happening is people go through the agency, they turn over, they don't have the expertise, so they go out, they have to hire them as consultants, which is great for them, right? But there's like a lack of institutional knowledge, like build up, and I think that is like going to be a really fascinating way of applying this technology. Is how do I truly institutionalize the knowledge of like how to do these things, how to take these processes that were invented 20 years ago that are still good today, and ensure that they can live on in the transfer of that knowledge. I think that's going to be like a huge role of human in the loop in this like, whole adoption.
You know, it's interesting because one of the things that I saw, and I love the branding of this, is that I think it's Microsoft and a few others have what they call Copilot now for our developers. If you're not in the software development, it's an amazing tool that it's kind of a Copilot. It sits next to you, checks your work, accelerates. We hear stuff like we'll see 30% productivity enhancements and all of that. But the idea is it's a Copilot that somebody sits next to you. I like that. I see Kyle smiling. Thoughts on this? And we've got a few minutes, and I probably want to open up the questions. So why don't you make it brief, and then we'll let Johannesburg.
There's one mundane, right? Maybe might be a good word for it. Like documenting code. You know, AI can do that for you now. And in fact, you know, just recently I've had this aha moment where I'm like, I don't have to document code anymore. I can just ask AI to do it. But in the sense of the question, you know, human expertise and decision making, especially when it comes to these large language models, you can't just, with these huge models, you really do have to verify, right? You can't just take what it you know, your college application and not review it before you submit it, right? That's probably a bad idea. So you do need to trust, but also verify. Again, particularly with these large language models. So don't just assume that Copilot's going to document your code perfectly the first time.
Yeah, so just to keep it brief, as you said, I think one thing probably is clear to everybody now, but obviously we know that models, AI models, etc., are not perfect. They make mistakes, they are only so good as they are. The same thing also, domain expertise can be often misguided. You know? There's cases where you work with some production company and build something that if you did it for 30 years, they didn't change it and suddenly it's better. You know? So all these things exist. And the interesting thing is, that's sort of why this is a really nice question, is actually how humans and algorithms, AI, can complement each other. And one thing we touched on was sort of a bit how humans can keep the AI in check. But there's also like a nice way how the AI can also make the humans better. You know, and this is something, there's different ways that this can happen, but we've had one case where we were working with people or with an organization where there were decision makers who were subject to a lot of data, you know? And there's all this data, they can look at this, 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 even more, and they have to make a decision based on the data. And okay, one thing is you can say, oh, I'm training the AI system to replace the decision maker. That's probably not going to work for all sorts of reasons, so we forget about this. But we say, can we make the decision maker better? And one way is to say, well, maybe we train a system that shows the person where to look. So they have to look at all the data and say, oh, maybe you look here on page 5, and here this column, this is interesting, and this is not unusual. And this doesn't just make this person more productive. What also happens is, next day you're not in the office, and somebody else is there. You know? And that person has different biases and has different methods. And so in this sort of project, one problem is also consistency. You know? With different people being in the office, in sort of operational setting. So again, if you have an AI system that supports you say where to look, what is unusual, what is difficult, you have a very nice way to actually like enhance the human. You know, but also make it more consistent across different people working there. You know, still the human makes a decision. You know, it's a decision made on data, but then the human is not like drowning in information. And it's not also dependent on, you know, who's the office today who knows about.
Okay. I think there's some great information, just trying to relate it back into our world. One of the things that I find incredibly important, and one of the reasons I think that we felt Earth was a great place to be, was the massive amount of data that this company has at its really at its fingertips now. You're talking somewhere in the neighborhood of 130 plus million tickets are coming to our system right now, the data that goes with it. So having great data, I think it's absolutely important. I'm not going to make this a big sales pitch, but it's the reason that the Insights, DigSights, what we used to call it, is the most powerful tool in risk understanding in the industry. And I say that not as a sales pitch, but just understand the complexity of data, and having more data makes it better. So if you're not using that tool, one of the things I wanted to relate, in my time, the biggest thing that I ever saw change was when we had GIS come in. GIS changed damage prevention. It went from having paper maps and folders everywhere to all suddenly now having the decisions being made automatically using GIS. That's what risk is. That's what AI is doing for us now. It's the next evolution of our industry. And I think it's really important that we not only take the ride, but we actually drive the train here. So I think it's really important. These guys will be around. I think all of you are here for the next both days. So if you want to get a chance to chat with them, please do. I'd like to have taken some questions, but I think we ran over just a bit. So I'm going to apologize. One thing.
I think we still can take one or two.
Okay, great. All right, perfect.
That's fine.
All right.
I think we can take one or two.
Okay. Does anybody have any questions for our experts? All right, Kevin. Wait a second.
I'm getting reprimanded for not, because they want to be able to hear the question on the video.
That's for Jason's show. Just circling back, I think from just an industry globally, it's the de-siloing of data. Like, is there a long-range strategy, maybe from Earth, or I know it's something as a one-call center, we've got many disparate data sources that getting that silo, you can use BI or something like that to try to do it, but it's really about configuring the database somewhere else that has already done that for you. So it's really just a discussion about that, the de-siloing, and I know you're doing some of it with damage data from the utility company, and then using that for insights, but like I look at it from an education component. We started today's conference off about the importance, of an educated staff, and there's a piece of data that we have that, let's de-silo it.
Like sometimes I feel like I owe Kevin like money because he sets me up very well. But I would say understanding risk, training on risk is very important after that. So two separate issues, the de-siloing of data I think is important. We can talk about that. But also the actions that you do based on the information you get. I think training is critically important. Once you identify what is high risk, then what do you do about it? We have a lot of clients that will run high risk and not do anything. And they can't imagine why things don't get magically better. And we said, well, you got to do something about it. Send a notification out, go out on site, do something to do it. When people started doing that, we actually saw the effects happen. We've got good customers that are showing that. But I think more importantly, though, as we're looking at de-siloing data, I think the conversation shifts really quickly back to the call centers in a lot of ways, because you guys sit on this jackpot of data. And the question becomes is when does your data become publicly available to everyone, right?
And the other component to that is you're saying, let's do education after we assign the risk. I think education contributes to reducing the risk.
Absolutely.
We already have that, but we're not able to.
I think if you ask Sam sitting right next to you, I don't think he can get 50% reduction in 5 years without better training, better education. I'm very interested in what the CGA is going to do and their path moving forward. I think there's a great spot to do great education, great training there that will help reduce damages. So, we're good?
Anything else? One more question, anybody?
All righty. So we're going to take a quick break. The one call centers that are here, our breakout session is going to take place where we had lunch. So if you guys want to make your way over there, we'll get started here in a few minutes. We're going to take a 15-minute break still.
Yeah. We'll try to keep it closer to 10, but yeah,
Okay.
15 at the longest. But like you said, Jason, the one call breakout is across the room. If you're not in that, come back to this room and we have another panel with owner-operators.
And then let's give a hand to our guests that joined us today. This is a real treat, so thank you guys very much.